Hello everyone, Salam alaikum. This is Group 6, and today we would like to present a regression algorithm for predicting the burned area of forest fire dataset. So, before we dive into the project, I would like to introduce my group members. We are in Group 6. We are Sabri Nasir, Muhammad Fuad, Mir ibn al-Din Muhammad, Muhammad Ibrahim, and Ahmad Amin and Ahmad Mukhtar. So, the first thing we would like to dive into the project is abstract. So this project focuses on predicting the burn area of forest fires in the northeast region of Portugal. Using the meteorological and other relevant data, a machine learning approach is employed to develop a predictive model using the regression algorithms. So the dataset includes meteorological measurements and spatial improvement information with the target variable being the burned area. So the report covers pre-processing, exploratory, data analysis, model construction, feature selection, and lastly, evaluations. So the project aims to provide insights for effective fire management and prevention of strategies contributing to early warning systems and resources allocations. So I will pass now to my classmate to dive into the introduction.
So the introduction for this project, this research project focuses on predicting the burned area for forest fire in the northern region of Portugal using the machine learning algorithm and regression technique. So by incorporating the meteorological variables and the contextual information, the projects aim to develop a robust predictive model to estimate the fire damage. The dataset undergoes pre-processing and exploratory data analysis and uncover the patterns and the correlation. The regression algorithm as well is being used to construct a predictive model which is evaluated using appropriate metrics like confusion metric, accuracy, F1 score, and so on. So the feature selection technique are applied to enhance the interpretability and the model generalized ability is assessed using spear testing dataset, which is when we do data preprocessing, we gonna perform data splitting where we split the data to like 80% for training and 20% for testing. So the outcome of the project can be informed resources allocation and fire prevention strategies and ecosystem management. Accurate prediction and burned areas contribute to early warning system and optimize the fire fighting efforts. This research builds upon existing knowledge in the field and providing a valuable insight to mitigating and impacts of the forest fire. So I will pass to my classmate to proceed with the related work.
Assalamu alaikum, this is me Muhammad Fuad, and now I'm gonna to explain the related work between five papers. As we see in the first paper, it belonged to Sun. It's published in 2012. This paper is focused in world fire size distribution models, and it used the methodology statistical analysis and modeling. The key finding insights into variability and patterns of brand area. The second paper, it belonged to Miguel. This paper was published in 2019. Its focus in relationship between methodology and fire danger. The methodology used evaluation of temporal dynamic, the key finding, understanding fire prone, conditional and seasonal patterns. And here the third paper, it belongs to Pereira. It's published in 2013. It's focusing in climate change and wildfire in Portugal. The methodology used in this paper, occurrences and burnt area, the key finding, changing dynamic of fire reg- uh, regimes due to climate change. And the fourth paper belongs to Russos. It's published in 2017. It's focusing on a relationship between drought conditional and fire weather. The methodology used analysis of drought indices, key finding complex interactions between drought, weather, and fire. And finally, the last paper, it's also belong to Rosa, published in 2017. It's influences of fuel mixture on fire spread rates. The methodology used development of fire spread models, key finding importance of fuel moisture in fire behaviors. And I'm going to pass to my friend to continue.
So we have here the methodology framework. As any data science or any related work to data mining, okay, we usually start by data collection or data set allocation, where we have to collect our own data set, or we have alternative option is to collect this data set from uh, global repository and so on. In our case, we have collect this data from UCI machine learning repository, and it contains a relevant meteorological and other data for the northeast region of Portugal. So the second phase we have here is the data pre-processing, which we perform the cleansing the data by addressing the missing values, encoding the categorical variables, and normalizing the numeric features. In the third phase, we have the exploratory data analysis (EDA), which is doing data set analysis based on the generating graphs like histogram and so on. The aim of EDA is to gain the insight into the dataset through visualization, correlation, and outliers and seasonal patterns. The fourth phase, we have the feature selection, which is done by identifying the influential variables using technique like select key the best, which is more suitable for scoring function. In the fifth phase, we have the model selection, where we choose the regression model that is suitable for predicting the burned area, considering the option like linear regression, decision tree, random forest, and support vector regression. Six, we have here the model training. We split the dataset into training and testing, as we mentioned earlier, and we choose the model and we adjust the hyperparameter for the optimal performance. We have also the model evaluation. We assess the model performance using metrics like MSE, RMSE, R square, and MAA, which is for mean absolute error, comparing also with baseline and existing research. We have also model optimization. We fine tune the model using different hyperparameter value and regularization technique. We have interpretation and analysis. We analyze the model to understand the significance of meteorological variable and their impact on fire behavior. We have deployment and application. We implement the optimized model with user friendly interface and API for practical usage and decision support system for the fire management as a fire management tool. Lastly, we have the documentation and reporting. We document the methodology, including the pre-processing, model selection, training, evaluation, and the insight differ from analysis. So I will pass to my classmate to proceed with the next slide.
Hello everyone, and I'm going to continue with the regression algorithm. Neural network, particularly feed for neural network with hidden layers, are commonly used regression algorithm for predicting burn area in forest fires based on meteorological and relevant data. These networks learn optimal wide and basis throughout training and back propagation, minimizing the discrepancy between predicted and target values. They excel at capturing non-linear relationships and complex partners in the data. The network architecture can be tailored to the problem complexity and available data. Loss function like mean squared error or mean absolute error quantify prediction errors, and optimization algorithm like Garden descent update the network's parameters. Lastly, neural network provide prediction for unseen instances by uncovering and delaying data partner throughout the training. So I will pass to my classmate to continue.
Okay, so regarding this is the analysis and design flowchart. We start with the random weight, where this is the first input of the entire system, and then apply different model architecture and input hidden and output layers with the neuron and functions training with the first set of data. So after that, we move to calculate error, and now we have an operational chart where there is a Boolean algebra where there is yes or no. So if the optimal model is achieved, then proceed with the select approach with the optimal model using different approaches. But if it's not a shift, then go back and apply a different architecture model. So let's assume now it's a shift. So we dive into the next chart, which select appropriate each model and optimal model with different approach. So after that, we dive into the validation and then evaluate error of the system. The Boolean algebra again goes if it's acceptable error a shift, then move to process the end. If it's not a shift, then go back to the beginning and reprocess from the beginning. So that's for the flow chart. And for the Sudo code, it works the same way almost as this flow chart. So we have the start on the first step and then input data. And then we have to load the data set inside the system. And then step three is data reprocessing. After we have data reprocessing, it includes handling missing values, includes encoding and categorical variables, normalize numerical features, and then step four is to split data. We split the dataset into training and testing sets. Step 5 defines the neural network architecture. These steps has define the number of input numerals based on the features and then define the number of output numerals, uh, one for each regression. So step 6, initialize neural network and then initialize neural network with a desired number of hidden layers and numbers. So, and then we choose the activation functions for each layer. And then step 5, we train the neural network. So for each of a push, forward propagation, and then for each training instance, calculate the predicted output using current weight and basis. So, and then we have the last step for step 8 is evaluate the performance. So for each testing instance, calculate the predicted output using the trained neural network and then calculate the issue metrics, for example, the MSE and then the MAE and the R square. So between the predicted output and actual target, we get to the last step. So I will proceed now. Next, please. I'll proceed now with the result and the discussion. So what the result and discussion has to offer us is the result and discussion section of the project presents the finding and analysis of a predictive model for estimating the burnt area of forest fires using meteorological and other data. So the section evaluates the model's performance using metrics such as mean square error, MSE, and then the mean absolute error, which called the MAE. So we visualize also representations such as scatter plots and line plots, and those ones are utilized to compare predicted and actual values. So the loss curve shows the model's learning progress, while in the MSEVs, the epoch curve that demonstrates the convergence, of the model's predictions. So the accuracy curve indicates of an increase of accuracy of the number of iterations. Increases also the visualizations and the metrics provide very valuable insight into the model's accuracy and converse and the improvements. So that was it for the results and the discussion on the flowchart. So I'll pass now to my colleague for the MSE graph.
For the main squared error, as we can see here in the figure, the MSE graph represents the change in the main squared error over different epochs of the training. The main squared error is a metric that quantifies the average square difference between the predicted value and the actual values. A lower MSE indicates that the model's prediction are closer to the true value, suggesting better performance. And lastly, analyzing the MSE graph allow us to track the convergence of the model prediction and assess whether the model is improving over time or if it has reached a plateau. Next slide. For the accuracy with the epoch curve, as we can see here in the figure, the accuracy with the epoch curve illustrates the accuracy of the model prediction at each epoch during the training process. Accuracy is a common matrix used to measure the performance of classification models and represent the percentage of correctly classified instances. The accuracy with the epoch curve provide insight into the model ability to make correct prediction as training progresses. Lastly, to see accuracy, no, no, uh, lastly, to see the accuracy increasing with the each epoch, integrating that the model is learning and improving its capabilities. So I will pass to my friend to continue.
Assalamu alaikum, this is Muhammad Ibrahim. I'll present the loss with epoch curve. The loss with epoch curve showcases the change is the change in the loss function over different epochs. The loss function represents a measure of the discrepancy between the predicted values and the true values. It quantifies how well the model fits the training data. The loss with epoch curve helps monitor the convergence of the model's training process. A decreasing loss value indicates that the model is effectively learning and reducing the error between predictions and the true values. In conclusion, in conclusion, next. In conclusion, this study aimed to predict the burned area of forest fires in the northeast region of Portugal using meteorological and other relevant data. The findings indicate that meteorological variables such as temperature, humidity, and wind speed significantly influence the burned area. Seasonal, seasonal patterns and trends also play a role in fire occurrence and severity. The regression models showed reasonable predictive performance, but further research is needed to improve accuracy and explore advanced techniques. Integrating remote sensing data (GIS) and real-time monitoring system can enhance predictions. Future research should consider socio-economic factors and land use information to develop more comprehensive fire management strategies. Continued research in this field will contribute to better understanding and mitigation of forest fire. And thank you so much.
Of this project. We have used the Google Colab environments, and we use Python programming language. Here in this node, we import necessary libraries for our projects. And from here, we can load the dataset into this environment. And as we can see here, this is the attributes of our dataset. This one is histogram representation of the area column. And we have here, we add a new column in the dataset, which is size category. And this is the visual representation of that column. And we have here the heat map, and it represents the, the attributes in the dataset. We have also distribution histogram for the burned area. We have another histogram for counting the plot of months in the dataset. And after we convert the months in the dataset, we convert it into seasonal. Okay, and after that, we perform a data selection. Okay, uh, and we select the summer season because it's more likely for the fire to happen during the summer, during the high rate of the temperature. And this is a visual representation histogram for the count of days. And this is a histogram representation for each variable in the dataset. We perform scaling area and rain, and this is histogram representation. And we perform a feature selection, feature scaling, okay, and using the standard scalar. And we initialize the model here, and we define the input dimension and the activation function like reload and the sigmoid function. And this is the training phase of the model. We give it 250 iteration, and we define an early stop. If the accuracy remain the same, so there will be early stop function, it will be activated. As we can see here, the accuracy stopped on 96%, and it did not increase, no further increase, so there is early stop function was activated. And as we can hear, as we can see here, this is the loss curve, the comparing with the epoch. As we can see, it decreases, the loss it decreases. And this one is the accuracy curve. As we can see here, with each epoch, it increased until it reached good accuracy. Lastly, this is the train accuracy. It was 92%, and the validation accuracy, it was 96%. Lastly, this is the MSI PS, the